what we're going to do is match the description with the set. So on the left-hand side, there's a description. On the right-hand side, there are the sets. First one we're going to look at is all numbers on the number line. All numbers on the number line, that's every number on the number line, is a real number. That's the set of real numbers. The real numbers are broken into two further sets. One is rational numbers, which we can, for now, we'll just say they are numbers that can be written as fractions. They can be represented as a fraction, like 1/3. And then there's the irrational numbers. These are numbers that cannot be written as fractions. So we look at a diagram of this. We have the real numbers, that's all numbers. And the real numbers are split into two distinct sets. Rational numbers, which are numbers that can be written as fractions, and irrational numbers, which are numbers that cannot be written as fractions. Below the set of rational numbers are other numbers, and we're going from the most general to the most specific. Right below rational numbers would be the set of integers, which are the positive and negative whole numbers. Now, there are rational numbers that are not integers. For example, 1/2. It's a rational number, but it's not an integer. So we're going more and more specific. The next set below integers would be the whole numbers. They're basically the positive integers and 0. And then the most specific set would be the natural numbers, the counting numbers. So we have our real numbers, and real numbers are all numbers on the number line. And below that, and there's your number line. So I can easily put in there, you see where 1/2 goes, or 1 3/4, or -3 5/8. They can all fit on the number line. Of course, it has arrows going in both directions. So any number on the number line is a real number. Real numbers are split into one of two categories. Either they're rational numbers, like so. 2/3 is rational because it can be written as a fraction. 1/2 is rational. Even 0.333 repeating is rational because that's the number 1/3. That can be written as 1/3. So if it repeats in its decimal notation, or it ends, it's rational. The number 6 is rational because it can be written 6/1. The number -5 is rational because it can be written as -5/1. So those are all rational numbers. An irrational number is a number, one of them you know is like pi. Now that's not the full representation of pi. It goes on forever and it never repeats. So it cannot be written as a fraction, so it is an irrational number. Some other examples are like the square root of 10, the square root of 11, the square root of 12. There's actually an infinite amount of irrational numbers. Numbers are either rational or irrational. Can't be both. We're now looking at the sets here. And from the most general, which is a real number, down to the most specific. So the natural numbers are the most specific set, and you can see like the number 5 is also a rational number because it can be written as 5/1. and rational numbers are numbers that can be written as fractions. So we can write any of these numbers, whole numbers, integers, over 1, which makes it a part of the set of rational numbers. We have another schematic here of our sets of numbers, and we're going to answer true or false to these numbers. The first one I just put in there to give you an example. All houses are 2-story houses. Now clearly that's false. And we can prove it's false if we find one house that's a ranch house. That's called a counterexample. So we just need to find one thing that's not true, and therefore the statement is not true. Counterexample on that would be a 1-story house. Now the second one, it says all natural numbers, and there they are integers. And you can see that's true. Now if we reverse it, it says all integers are natural numbers. All integers are whole numbers. Now you can see the -1 is an integer, but it is not a whole number. So there's a counterexample. It is not true. It is false that all integers are whole numbers. And finally, we have all whole numbers are real numbers. Well, there's the whole numbers, and we know that real numbers are any number on the number line, and certainly whole numbers are on the number line. So that's true.